Hello, my name is Maria Miller from mathmammoth.com. In this lesson we're going to study slope. Now slope, informally speaking, is the steepness of the line. We're going to graph some lines here and I have some over there too. So it's basically the steepness of the line. Now more technically speaking, it is defined as the ratio of the y increase compared to the x increase. We'll look at that in a moment. First, let me plot this particular line. Y equals 2x. So the y values are double of these x values. 0, 2, 4 and 6. And let me plot those points now. We have 0, 0 at the origin. Then 1, 2, 2, 4 and 3, 6. Notice here that whenever x increases by 1, y values increase by 2. We can see the same here in the graph, that if I'm here on the graph, this point is on the graph, and I go 1 unit x ways, then I have to go 2 up. Like that, 1, 2. If I go 1 unit this ways, I go 2 up. And so I get these triangles here, and from this triangle you can get the slope. The slope is 2. You can see it here in the equation, the slope is 2. You can see it here in the triangles if you look at this 2 to 1 ratio. Okay, this ratio 2 to 1 is the slope, but it simplifies to 2 in this case. And you can see it here too. Whenever x increases by 1, y increases by 2. The slope is 2. It is the ratio of the y increase compared to the x increase. Y increase 2 compared to the x increase 1. Now let's look at this one, y equals 5x. You can see from the equation the slope is 5, or the steepness is 5. We will expect to see a line that is much steeper than this one. It's going to be going vroom, really steeply. And I get these points here. In this table you can see that whenever x increases by 1, y increases by 5. And let's plot those. There's 0, 0 here, then 1, 5. And 2, 10 is already beyond where I can draw it. But I can draw the line now, just using these 2 points. So this is y equals 5x. And whenever I go 1 unit this way, I go 5 up, okay? So my triangle would have 1 and 5. Here, we can see from the equation that the slope is going to be 1/2. And again, when I calculate these y values, it is just half of each x value, right? And so whenever x value increases by 1, going this way, the y values are increasing by 1/2. And plotting it here, we have 0, 0 again, and then 1 and 1/2. Somewhere there, and then 1 and 2. Okay, let's draw the line now. So here, if I draw a triangle, I go 1 unit x ways and half unit y ways. I go half and 1. The slope is always the ratio of the y increase to x increase. The slope is therefore half to 1, or 1/2. You can also look at the slope this way. You can make this kind of a triangle, go 2 this ways and 1 this ways. So there's 1 and 2. The slope is again, take the ratio of the y increase to x increase, 1 to 2. And this one here, look, it has negative 3x. The slope is negative 3. The slope can be negative, and whenever the slope is negative number, then we have lines that go downhill, okay, instead of uphill. So here we get 0, then negative 3, negative 6, negative 9, negative 12. Whenever x increases by 1, y values decrease by 3. And so to draw this line, it is again goes through the origin, and then 1 and negative 3 over here. So this line goes downhill, its slope is negative 3. If I draw the triangle, I go 1 unit in the x direction and I go 3 units down. So the ratio of y increase to x increase is actually -3 to 1. And the slope is -3. Now let's go over here, find the slope of these lines. And what we will do is we will draw those triangles. For example, A. So I will go 1 unit in the x direction and then check here. This is 3 units up. Okay, so the slope is simply 3. I can also write the equation of the line, which is, of course, y equals now 3x. In B, my triangle would go maybe like this. Okay, the y increase is just 1, and then I went 4 units x ways. Now look at the ratio of this to this. So the slope is 1/4. And the equation is y equals 1/4 times x. And then lastly, the brown line. Okay, I have a point here, so I could go a triangle like that, and it has 2 units going down and 3 units in the x direction. So I take the y increase or decrease over x increase. So this is 2/3, except that it's going downhill, so I need to take it negative. And the slope is therefore -2/3. And the equation is y equals -2/3 times x. Now lastly, we're going to take just a peek at these kind of lines that don't go through the origin. If you notice all these examples here, 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 each single one went through the origin. And the equations were of the form y equals slope times x. Very simple ones. Now, these ones that don't go through origin also are almost the same type of equations, and they do also have a slope. The slope we can find the same way. We just find 2 points on the line and then draw a triangle. And then we compare the y increase to the x increase. There's 2 here and 1 here, so the slope is 2 divided by 1, or 2. The slope for this line is 2. Its equation, though, is not exactly this one. It is almost. The equation is this, and then we add or subtract a constant, a number here. In this case, we will add 1. And the number we add is wherever this line crosses the y-axis. This line here crosses y-axis at 1 unit. So therefore we add 1 to the equation. And the second line, if I want to study the slope, I could draw a triangle here. Okay, or the same one this way. Like that. And it has 2 here, 1, 2, 5 here. So the ratio of y increase to x increase is 2 to 5. And that's the slope. And the equation is y equals 2/5 times x, and then plus or minus some number. This time this line crosses the y-axis at -2, so we subtract 2 to get the equation of the line. So we're all done, and I hope this was helpful.